Okay, so we are going to take a look at today 9.1 Graphing Quadratic Functions, Part 2. And just to recall, anything that has an x squared like this is going to be a parabola. And if you recall from last class, we graphed these by making a table of values. And so today we want to investigate them a little bit more. So first of all, we have each parabola has either a maximum or a minimum, okay, lowest or highest point on the graph. The maximum or the minimum is always going to be the vertex. Okay, so if we look back at, some of the ones on our previous lesson, right? So we can see, like, here's the vertex. That would be a minimum. It's the lowest point. Here's the vertex. It's a minimum. It's the lowest point. Here, the vertex is the highest point, so that would be a maximum. And one of the things, when we have a maximum, you'll notice that the equation started out with a negative. When it was the minimum, it was always a positive value. So that's actually what I have here. If A is positive, the vertex is a minimum. If it's negative, then it's a maximum. So in other words, like an example would be y equals a positive x squared. That's going to look like this. So our vertex would be here, a minimum. And then if it's negative, for example, if it's a negative x squared, our graph would go down, and so the vertex would be a maximum. Now, domain and range. If you recall, domain, we think of all the possible x values, and the range are the possible y values. Okay, so with a quadratic, the domain is always all reals, because we can technically plug anything we want in for x. We can plug in negative values, we can plug in positive values, we can plug in decimals, fractions, 0, any of those. But the range is not all reals. The range is determined by the y-coordinate of the vertex. So if the vertex is a minimum, then the range is y is greater than the y-coordinate of the vertex. Oh, that should say maximum. If the vertex is a maximum, then the range is going to be less than. I'm going to go over all this. This is a lot of detail to remember, so when we go through the example, I'm going to refer back to this box. Then we have something called the axis of symmetry, which I briefly talked about last lesson. The axis of symmetry is the one that cuts it right in half. So, and it's going to be x equals negative b over 2a. You should recognize that formula because that is the same formula we use to find the x-coordinate for the vertex. And lastly, the y-intercept. So we had y-intercepts when we did equations of lines. The y-intercept here is always going to be the constant because basically when you substitute x in for 0, we'll just get the constant. Again, I know that's a lot of information. I think it's going to be easier to determine when we go through some examples. Okay, so we want to identify the vertex, determine whether it's a maximum or minimum. We're going to circle that. Then find the domain, range, axis of symmetry, and the y-intercept. So all that stuff that was in the box above. So first thing we want to do is let's identify the vertex. I can see here the vertex is there, and that's, so if we look at the points on the graph, the x-coordinate would be a -1. And the y is at -4. Is it a maximum or a minimum? Is it a low point or a high point? It's all the way at the bottom, and the graph points up. So definitely that is a minimum. Next, our domain. I said you're automatically going to put in all reals. Now the range. The range are going to be all the values. So since this was a minimum, we're going to say here y has to be greater than or equal to, what is the y-coordinate of the vertex? It's -4. So y has to be greater than or equal to -4. So basically we're looking at all the y values. Since it's pointing up, that's why it's greater than or equal to -4. Next, we want to find the axis of symmetry. So the axis of symmetry, again, this is the line that goes right through the middle, okay? And if we're unsure, so it's going to be x equals -b over 2a. Now, we don't see those values, but we have the graph. So what is the equation of this line? It's x equals -1. So we just look at what is the x-coordinate of the vertex. And lastly, we want to find the y-intercept. So we look for, here's, right, we have our y-axis is here, and we want to look for where does this graph cross. So where do they overlap? Right there. And that point right here is the point 0, -1. Okay, let's look at another one. We have the vertex. Right here is the vertex, and that looks like the point 3, 5. This time it's pointing down, so that makes it a maximum. That's the highest point. Domain, all reals. Now, since it's pointing down, the range is going to be less than or equal to. So remember, back here I said when the vertex was a maximum, the range is y less than or equal to. But what is the y-coordinate? It's 5. Because our range, so think of the range as where does it start and where does it continue? So it starts at 5 and it goes less than. So that's why we put less than or equal to. Axis of symmetry. So I'm going to draw the line straight through the middle. And I look at what is this equation of this line? It's x equals 3. It's always the x-coordinate. And finally, the y-intercept. So I look for where does it cross? Here's the y-axis. It crosses right at -4. So it's going to be 0, -4. Okay, maybe you want to try C on your own and then check back to see if you get the answers right. Our vertex here is at -3, -5. It is a minimum because it's the lowest point. The domain is all reals. And the range, so when it's a minimum, right, it's starting here at -5, a y value of -5, and it's pointing upward. So it's going greater than or equal to -5. Our axis of symmetry goes right through the vertex, and it's always x equals, and this is x equals -3. And the y-intercept this time, it crosses here at +4, so it's 0, 4. Okay, now for the next examples, I'm going to give you the equation, and we're going to do all the same things, okay? So this, instead of just looking at the graph, we're going to go based on the equation of the quadratic. Okay, first thing, I want to find the vertex. Now remember, vertex is -b over 2a. A is 1, b is 10. So I have -b over 2a, which gives us a -5. So that's the x-coordinate. Now, to find the y-coordinate, we need to plug it in to our equation. So I have y equals -5 squared plus 10 times -5 minus 5. So this will give us 25 minus 50 minus 5. So 25 minus 50 is negative 25. Minus 5 is negative 30. So negative 30. Now I don't have a graph, so I don't have that visual, but we can tell if it's a maximum or minimum based on if this is positive or negative. It's positive. So I said when A is positive, I have a minimum. Because remember, if it's positive, that means it's pointing up, which makes the vertex the lowest point. So that's a minimum. Domain, always the easiest one to answer. That's going to be all reals. Now remember, since I said it was a minimum, right? It's going to be pointing upward like that. So that means my range, whenever it's pointing up, it's starting from the lowest point and it's going greater than or equal to. Where is it greater than or equal to? The y coordinate of the vertex. So y is greater than or equal to negative 30. My axis of symmetry is always x equals negative b over 2a, which again, that's my x coordinate of the vertex. So x equals negative 5. And lastly, we have the y-intercept, which is 0, comma. So what happens if I plug 0 in for x? I get c, which is my constant, is negative 5. So all I need to do is take that y-intercept, making it when x is equal to 0, I get negative 5. It's always going to be the constant. That was the other thing I had mentioned here. I said always going to be the constant. Okay, let's try another one. So let's start with the vertex. It's going to be negative b over 2a. So a is negative 1, b is equal to 8, and we'll label c as well. We're here, so negative 9. So x is negative b, so negative 8, over 2a. So that's 2 times negative 1. Negative 8 over negative 2 gives us a positive 4. Now I want to find my y-coordinate. So y is negative 4 squared plus 8 times 4 minus 9. So that's going to be, we're going to do the power first, which is 16, and then we take the negative of that. So negative 16 plus 32 minus 9. So I have negative 16 plus 32 is 16, and then 16 minus 9, we get 7. So 4 comma 7. Okay, this one has a negative. So I know when it's negative, it's going to be pointing downward, which makes the vertex a maximum. Domain is all reals. The range, it's pointing down, so it's going to be y is less than or equal to what value? The y coordinate of my vertex, which is 7. Axis of symmetry, x equals negative b over 2a, which is my x coordinate of the vertex, which is 4. And finally, the y-intercept is going to be 0, comma, what is my value of c? It's negative 9. Next, let's see, a is negative 3, b is 12, c is negative 1. So x equals negative b all over 2 times negative 3. That's a, so negative 12 over negative 6, which is 2. So that's the x coordinate. The y coordinate, I have negative 3 times 2 squared plus 12 times 2 minus 1. So I have negative 3 times 4, which will make that negative 12 plus 24 minus 1. So that'll be 12 minus 1, so 11. So 2, 11. This is a negative, so that means it's going to be pointing down, which makes the vertex a maximum. Domain is all reals. Range It's pointing down, so it's going to be y is less than or equal to the y coordinate, which is 11. Axis of symmetry is x equals 2, the x coordinate of the vertex. And then the y-intercept is 0, comma, -1, because that's our value of c. Okay, last example, we're going to put it all together and we're going to graph it. All right, so vertex, x equals -b, so a is 1, b is 2, c is -3. So -2 over 2 times 1, so that's going to be a -1. And then I'm going to substitute -1 in. So I get 1 minus 2 minus 3. So 1 minus 2 is -1, minus 3 is -4. It's a positive x squared, so that means it's going to be facing up. That makes it a minimum. Domain is all reals. Range, it's pointing up, so it's going greater than. So greater than or equal to y coordinate, which is -4. Axis of symmetry is x equals -1. Y-intercept is 0, comma, what is my value of c? It's -3. Now, we can already see -1, -4, there's my vertex. And I know it's got to face upwards, so I know it's going to go kind of like that. So later on when we do graphs, especially like in Algebra 2, it's really helpful to just have a quick sketch. Here, we already know the vertex, right? We said that was -1, -4. So if I count backwards, just a quick review, add 1, so forward, and then we're going to substitute values. Now, remember how I said this is always going to have symmetry? So I'm actually going to use these two values to substitute in. It just makes it a lot easier, right? So if I plug in 0, 0 squared plus 2 times 0 minus 3, I get -3. So 0, -3. And as long as I pick the values just right, that means -2 and 0 will have the same y-intercept, or have the same y-coordinate, so -2, -3 here. And the reason I did that was 0 and 1 are much easier to substitute in. So next I'll plug in 1, so 1 squared plus 2 times 1 minus 3. So that's going to be 1 plus 2, 3, minus 3 is 0. So that means -3 also has to have 0 as my y-coordinate. So I'll plot the other points here. So -2, -3. I already plotted the vertex. 0, -3, and 1, 0. There we go.